So let's make our application concurrent. What I want to do is introduce another queue with another thread and offload some work to that thread and free the UI thread for things that it needs to do. And those are UI things like interacting with the user and measuring and displaying and things like that. So as before, we have work that lands on our main queue and accumulates and gets handled by the UI thread. So let's say here as before, we are handling a tap and some other things occur. Well, I've created another queue and I've given it a name. The SDK allows us to do this. It creates what's called a serial queue by default, which means it's a queue just like the main queue. It has a thread just like the UI thread, except it can run concurrently to the UI thread. So work is going to land on this queue. Let's say that I called it the database queue, so this is where I'm going to do database work. I got some data from a remote endpoint and I'm going to save it in the database. And I'm going to save some skin data in the database. So this can be occurring concurrently with work that's happening on the UI thread. So this allows me to offload work onto another queue and let the UI thread be freed to do UI things. This is the most basic principle that you're going to employ as a mobile developer, and that is offloading work from the UI thread to other queues. And this is the most simple example. It's another serial queue. It does one thing at a time and it frees the UI thread to do UI things. A typical application does lots of different things. So I was retrieving data and inserting it in the database from my other queue. I want to create a second queue because this is where my networking is going to occur. I make lots of network requests to retrieve data, to go and cache images. So as you can see here, I've got quite a few pieces of work piled up in the Data Dragon queue. So I have jobs 6 through 1,575 because I have so many images to go cache. This thread is doing one thing at a time. So right now it's busy retrieving one of the images. So the problem with this is that since it's serial, I can't retrieve all 1,575 images until each one completes independently. So it's going to finish 5 and then it's going to go get 6 and it's going to go retrieve that, and then this thread is blocked. So this is going to take a while. This isn't ideal, but it is an approach to concurrency. I just create more queues. So that's all good and well, but it's going to take forever for me to go execute all 1,575 jobs because I can only do one piece of work at a time. I have one thread and the queue just builds up all the work. Let's make a slight improvement to that. I'm going to instead I'm going to replace that serial queue with a system concurrent background queue. iOS allows us to create or access one of these. It's shared and it's concurrent. The number of threads that are allocated to the queue are dependent upon several things, and we can't really predict or determine how many threads there are. It's based upon the number of processors that your device has, how many other serial queues are active and performing work, and what else is going on your system. So by accessing the shared system concurrent background queue, I still dump work into it, but let's just use this as an illustration. There are 4 threads that pull work from this one queue. This suddenly allows me to quadruple the amount of work and the amount of throughput for performing this task. So if I want to offload the work of caching all the images and retrieving all the network data to this system concurrent background queue, I add all the work in here, but suddenly I have jobs 5, 6, 7, and 8 all running concurrently. And as soon as one finishes, it pulls another. So I have 4 things going at one time. This is a drastic improvement over the previous version. So let's just summarize what we have here. We have the main queue feeding the UI thread, and we're going to use that to isolate only work that is necessary to run on the UI thread. That's user interaction, painting, drawing things, laying out the UI, etc. I have a database queue, which is a serial queue, and SQLite for the most part requires a serial queue because only one thread can access the database at a time. Now there's a few workarounds for that, but let's just make that assumption for now. And that's one thread doing all database operations. And then I have a system concurrent background queue running all my network operations, caching data, and this is the model that works. This is what I'm going to move forward with, and this is a strategy for concurrency that I'm using in the demo application.